Hello friends, today we will talk about testing for normality, so let's get started. In the last lesson, we learned that some capability indices require process data to follow a normal distribution. It's crucial that we check this assumption before calculating capability indices. The normal distribution is a bell-shaped symmetrical distribution that has a peak. It is defined by the mean and the standard deviation. The mean or mu is where the peak of the distribution occurs. The spread of the data is indicated by the standard deviation or sigma. Recall that the past production at a busy company, the process manufactures parts to have a certain diameter. So how do we determine if the part diameter data are adequately modeled using a normal distribution? Several tools are available to help us test data for normality. For example, histograms, normality probability plots, hypothesis tests. So first, let's look at a histogram with a normal curve. This is a histogram of part diameters. Now look at the normal curve that has the same mean and standard deviation as the data. The curve is a good fit to the data, which indicates that these data are modeled well by a normal distribution. We can also assess normality with a probability plot. The fitted line represents the assumed distribution. The dots are individual data values. To determine if the data are from a normal distributed population, we look at the plot and assess how closely the data values follow this line. Data that stray from this line indicate that they also stray from the normal distribution. So based on this probability plot, do the part diameter data follow a normal distribution? The part diameter, you can see here the part diameter values follow the fitted line. So it suggests the normal distribution in an adequate model for this data. In addition to histograms and probability plots, we can also use hypothesis tests discussed in Chapter 3 to test the data for normality. Start by stating the null and alternative hypothesis. The null hypothesis is that the data are sampled from a normal distribution. The alternative hypothesis is that the data are not from a normal distribution. If we reject the null hypothesis, we conclude that the normal distribution is not good fit to the data. In Minitab, the results of the hypothesis test are shown on the probability plot. The Anderson-Darling test statistic, shown here as ID, measures how much the data deviate from the best fitting normal distribution. The p-value is the probability of collecting a sample from a normal distribution with a test statistic greater than this value. So if you want to conduct a normality test by using Microsoft Excel, here is 10-step guide for your reference. Recall from Chapter 3 that we compare the p-value to alpha, which is the significance level for the test. We'll use alpha of 0.05. In other words, if our data really are from a normally distributed population, then we have a 5% chance of incorrectly concluding that the data are not from a normally distributed population. Here the p-value of 0.335 is greater than 0.05, so we fail to reject the null hypothesis that the sample data are from a normal distributed population. The hypothesis test verified that our data satisfy the normality assumption for capability studies. Let's review. We always check that our data follow a normal distribution before calculating capability indices. We assess normality using a histogram, uh, a normality, a normal probability plot, or the Anderson-Darling hypothesis test for normality. Thank you for your listening. In the next lesson, we will talk about the capability indices.